Today we are going to discuss problem on Gauss Divergence Theorem. In this, first you see that if the question is asked to evaluate volume integral, then you find surface integral. If the question is asked to find out surface integral, then you evaluate volume integral. If the question is asked to verify, then you have to show LHS is equal to RHS. Coming to the first question, evaluate surface integral f bar dot n bar ds if f bar is equal to x y I bar plus z square j bar plus 2yz k bar over the tetrahedron bounded by the lines x is equal to 0, y is equal to 0, z is equal to 0 and the plane x plus y plus z is equal to 1. So coming to the given question here, the question is asked to evaluate surface integral, means you have to find out the volume integral here. Then the question f bar is given directly in terms of I, j, k. Then the line equations are given x is equal to 0, y is equal to 0, z is equal to 0. Means the lower limits are given for x, y, z as 0. Now with the help of your plane equation x plus y plus z is equal to 1, you have to calculate the upper limits. Coming to the solution. Given f bar is equal to xy I bar plus z square j bar plus 2yz k bar. This is the given equation. Next, given planes are x is equal to 0, y is equal to 0, z is equal to 0. As we said, these are the line equations and these line equations are the lower limits of x, y, z to calculate your volume integral. Next, given plane equation x plus y plus z is equal to 1. With the help of this plane equation, you are going to find out the limits of upper limits as for x, y, z. Now using our divergence theorem is given by surface integral f bar dot n bar ds is equal to volume integral div f dv. So div f is nothing but you are going to find out del dot f bar here. Then you are going to substitute volume integral dv as dx, dy, dz. Since surface is given, you have to find out volume integral here. For our convenience, we have written this volume integral as I is equal to divergence, so in volume integral div f into dv. dv we said that it is written as dx, dy, dz. Divergence of f bar it is written as del dot f into dv of volume integral. So now we are going to substitute del is equal to I bar into dou by dou x plus j bar into dou by dou y plus k bar into dou by dou z. F bar it is given in the question. By using our dot product, we will be simplifying these two values. On applying the dot product and simplification, we get I is equal to volume integral 3y 3 dx, dy, dz. Now you have to calculate the limits of our volume integral. For that, we have taken the first limit, that is z. In the previous video, we have discussed how to calculate the limits and what preference should be given in the xyz values. So first you will be giving the limit of z. For that limit of z, z is equal to 0, lower limit it is already given in the question. From the plane equation x plus y plus z is equal to 1, you will be finding z in terms of x comma y. So you will be writing as z is equal to 1 minus x minus y. So your z limits are 0 to 1 minus x minus y. So from z equation, that is z is equal to 1 minus x minus y, from this equation you will find out the limit y value by substituting z is equal to 0. So from y limits and x limits, whenever you find, you will be using the previous limit and you will find out the limit of y and x here. So for y you will be substitute z is equal to 0, we get y is equal to 1 minus x. So the limits of y will be taken as 0 to 1 minus x. Since y is equal to 0, it is already given in the question. Now to find out the limit of x, put y is equal to 0 in y is equal to 1 minus x equation to find out the x element. So if you are substituting, you got x is equal to 1 here. X is equal to 0, it is already given. So x limits are 0 to 1. Now we got the limits of x, y, z. You are going to substitute these limits in our integral, volume integral, as I is equal to x is equal to 0 to 1 integral, y is equal to 0 to 1 minus x integral, z is equal to 0 to 1 minus x minus y integral, 3y dx dy dz. 3 is constant, you bring out of the integral. So first you will be evaluating with respect to z, since z is having two variables here. So next followed by y, since y is having single variable, then you will be evaluating the constant, that is x is equal to 0 to 1. Every time you see that you integrate first variables. In that variables also, if you are having two variables, you first integrate that one, then followed by single variable, then followed by constant integration. So first you are integrating with respect to z. So we will be collecting the integration with respect to z. Here we have taken integral of 0 to 1 minus x minus y dz. Now first you integrate this particular part, you will be getting z. Then apply the upper limit minus lower limit. On applying the upper limit minus lower limit, we get the value as I is equal to 3 of integral 0 to 1, 0 to 1 minus x, 1 minus x minus y into dy dx. Now you have to integrate with respect to y. For that, if you observe in this equation, you are having 1 minus x. Here in this equation, y is not present. So when you are integrating with respect to y, this term becomes constant. For that, we have taken these two values as one value, keeping in the brackets, so that easily you can integrate with respect to y. Now you multiply this y with respect to your equation, you will be getting 3 of integral 0 to 1, 0 to 1 minus x integral 1 minus x into y minus y square dy dx. Now you collect all the y terms with respect to your integration limits of y. So on applying the integration with respect to y, we get 3 of integral 0 to 1, 1 minus x y square by 2 minus y square integral is y cube by 3. You are having the limits as 0 to 1 minus x. Now you apply the upper limit minus lower limit. On applying the upper limit minus lower limit, on simplification we get I is equal to 3 into 1 minus x whole cube 1 by 2 minus 1 by 3 into dx. In both the cases you are having 1 minus x whole cube, we have taken outside. On simplifying this total value, we get integration as I is equal to 1 by 2 0 to 1 1 minus x whole cube dx. Completely on simplifying integration of y with respect to the limits, on simplification we got this value. Now coming to this equation, if you are able to remember a minus b whole cube, you apply the formula. Otherwise, there is a small technique to integrate this one. Here if you have seen, you are having 1 minus x. Here x power degree is 1 and you are having whole cube. So you assume this total value, whatever you are having 1 minus x, you assume this total value as x. It will be in the form of x cube. Now you are integrating with respect to your x cube. X cube integration you are writing as x power 4 by 4. But in place of x you are having 1 minus x. So you will be making as 1 minus x whole power 4 by 4. This technique is applied only when you are having the inner function x degree as 1. Then you have to integrate, make it the derivative of the inner function. Here inner function you are going to make it in the denominator. 1 derivative is 0, minus x derivative is minus 1. Either you can apply integration like this, or you can expand in the form of a minus b whole cube and you can apply the integration. So directly I have applied the integration instead of applying the formula of a minus b whole cube. So I have written as 1 by 2 1 minus x whole power 4 divided by 4 into derivative of the inner function, and then you are having the limits as 0 to 1. Apply the upper limit minus lower limit. On simplification we get I is equal to 1 by 3. This question is applied only to evaluate when line equation is given here.